Problem sheet 2, question 3. A mental health doctor is trying to understand a patient's mental state. They ask the patient to record daily whether they feel calm, mildly anxious or very anxious. Crunching the data, the doctor finds that on a calm day, a third of the time they'll remain calm tomorrow and 2/3 of the time they'll remain anxious tomorrow. On a mildly anxious day, a quarter of the time they will become calm tomorrow and half the time they will remain mildly anxious tomorrow, while a quarter of the time they will become very anxious tomorrow. And on a very anxious day, only a fifth of the time will they become calm tomorrow, 2/5 of the time they will become mildly anxious, and 2/5 of the time they will remain very anxious tomorrow. Draw the discrete time Markov chain describing the patient's mental state. Usually, drawing a Markov chain involves drawing states as ovals or circles and transitions between them. Here we have 3 states. We have the state of being calm, the state of being mildly anxious, and a state of being very anxious. The first bullet point indicates that when on a calm day, a third of the time they will remain calm tomorrow. So there's an arrow between calm and calm with probability 1/3. 2/3 of the time they will become mildly anxious tomorrow. So there's an arrow between calm and mildly anxious with probability 2/3. The second bullet point, on a mildly anxious day, a quarter of the time they will become calm tomorrow. Half the time they will remain mildly anxious. And a quarter of the time they will become very anxious. Finally, on a very anxious day, only a fifth of the time will they become calm tomorrow. 2/5 of the time they will become mildly anxious. And 2/5 of the time they will remain very anxious. And this would be the visualization of the Markov chain describing the patient's mental state. It would also be useful to be able to write down the transition probability matrix. In order to do that, we would have to order the states. So let's order calm as the first state, mildly anxious as the second, very anxious as the third. And so our transition probability matrix would become a third, 2/3, 0, because there is the probability 0 of going from calm to very anxious in one time step. A quarter, a half, a quarter, a fifth, 2/5, 2/5. The next part of the question asks us to find the steady state probabilities. So a steady state probability would be a vector of probabilities of being in each state. Let's call that pi. And it would be steady state when the probability of being in each state tomorrow is the same as the probability of being in each state today. We also know that this is a probability vector, so the sum of that vector will be equal to 1. And now we are asking, can we find these steady state probabilities? And so expanding this system of equations out, where pi, the steady state vector, is the vector, the probability of being in state 1, probability of being in state 2, and the probability of being in state 3, we will get pi 1 is equal to a third pi 1 plus a quarter pi 2 plus a fifth pi 3. Pi 2 is equal to 2/3 pi 1 plus a half pi 2 plus 2/5 pi 3. Pi 3 is equal to 0 pi 1 plus a quarter pi 2 plus 2/5 pi 3. And finally, adding all the probabilities together will equal to 1. Now, in order to solve this equation, we have to do a lot of manipulation, so it would be useful to number our equations. Number this first equation as equation 1, this second equation as equation 2, the third as 3, the fourth as 4. And it would usually be useful for us to express everything in terms of one of the pi's. Now, looking at these equations, it doesn't matter which pi we choose. Looking at equation 3 first, this only has 2 unknowns, and so it would be easier to manipulate this. So we have pi 3 is equal to 1/4 pi 2 plus 2/5 pi 3. This would mean minus 2/5 from both sides. We would get 3/5 pi 3 is equal to 1/4 pi 2, and multiply through by 5/3 would give us pi 3 is equal to 5/12 pi 2. And this would be a useful equation, so let's label that as equation 5. Now let us choose any of the other equations where we have 3 unknowns. With this substitution of pi 3 is equal to 5/12 pi 2, we can turn that into an equation of 2 unknowns. So let's, for example, choose equation 2. Now we could have chose any of the equations. I just arbitrarily chose number 2. I'm going to make the substitution that pi 3 is equal to 5/12 pi 2. And simplify this. A half plus a sixth is 2/3. So take away 2/3 pi 2 from both sides and multiply through by 3. So we get the relation that pi 2 is equal to 2 pi 1. So let's label that equation 6. Now going back to equation 4, which was our equation stating that all probabilities sum to 1, but substituting in the relations 5 and 6 that we just found. So we have 1 is equal to pi 1 plus pi 2 plus pi 3. We have 1 is equal to, if pi 2 is equal to 2 lots of pi 1, then pi 1 is equal to half pi 2. Pi 2 is just equal to pi 2. And we know that pi 3 from equation 5 is equal to 5/12 pi 2. So we can factor out pi 2. We get 1 is equal to 23/12 pi 2. And so pi 2 is equal to 12/23. Now, from all the relations we know so far, we know that pi 2 is equal to 12/23. We know that pi 1 is equal to half pi 2, which must be 6/23. We know that pi 3 is 5/12 of pi 2, so we could work that out, but we also know that the sum of all these is equal to 1, and so pi 3 is whatever's left over, which is going to be 5/23. Therefore, our steady state vector is going to be 6/23, 12/23, 5/23. And the final part of this question, the doctor devises a medication plan. On calm days, the patient should not take any medication. On mildly anxious days, they should take a pill of type A, costing 1 pence per pill. And on very anxious days, they should take a pill of type B, which costs 23 pence per pill. What is the expected yearly cost of this medication plan? Well, the expected yearly cost of the medication plan would be for 365 days per year. They're going to take a pill costing 1 pence with probability that they have a mildly anxious day, which is pi 2, plus a pill costing 23 pence with the probability that they have a very anxious day, pi 3. On calm days, they don't take any pills, which cost nothing. We now know what pi 2 and pi 3 is. This is going to be 365 times 1 times 12 over 23 plus 23 times 5 over 23, which is going to give me 2015.43, and this was in pence, so therefore that is going to be equal to £20.15.